a particle move so that after t seconds, its position vector is r, where r equals to 4t minus 1I plus t squared j plus 15t minus t cubed k meters. Calculate the velocity of the particle v in terms of t. To calculate the velocity of the particle v, I need to differentiate the position vector or the displacement vector with respect to time. That's the formula. And you see the position vector r is equals to 4t minus 1 unit vector I plus t squared unit vector j plus 15t minus t cube unit vector k. As you can see, this vector is having 3 dimensions or 3 components. That is the I component, the j component, and the k component. I, j, and k are unit vectors. You know, if we have a Cartesian plane of 3 dimensions or 3 components like this, we call this the x-axis, this is the y-axis, this is the z-axis. The unit vector I is always along the x-axis and the unit vector j is always along the y-axis, while the unit vector k is always along the z-axis or the z-axis. So to differentiate this vector, I need to label this as x-axis, I label this one as the y component, the y-axis, and this one as a z component. You know that if r is equals to xi plus yj plus zk, we differentiate component by component. That is, dr dt will be equals to dx with respect to t I plus dy dt j plus dz dt k. So this is the same formula I am going to use here. In this case, x is equals to 4t minus 1 and the y is equals to t squared, while the z component is equals to 15t minus t cube, and the dx dt is equals to the differentiation of 4t minus 1 with respect to time. That is the same like the differentiation of 4t with respect to time minus the differentiation of 1 with respect to time. You know, to differentiate an expression like this, you need to differentiate term by term. I know term in mathematics is always separated by a positive or a negative sign. So you separate at the level of signs. That is the level of negative and positive sign, like what I've done like this. Now, I need to differentiate 4t with respect to time. To do this, I will use the differentiation formula, which says that if y equals to x to the n, it means dy dx is equals to the differentiation of x to the n with respect to x, which is the same like n x to the n minus 1. So this is the formula I will use. In this case, my x here is t. It means the differentiation of 4t is 4. You know, it's like 4t is the same like 4t to the power 1. Since any variable or number is always raised to power 1. So it means that my n here is like 1. So I'm going to take 1 times 4 to the power 1 minus 1, which will give me 1 times 4 is 4. That's 4t to the power 0. I know anything raised to the power 0 is 1. So it means that I'm going to have 4 times 1, which is 4. That is why I'm having 4 here. And the differentiation of 1 is 0. It is 0 because the differentiation of any constant is always 0. Thus, a constant is any term that is independent of the variable. That is a term in which the variable is not attached. As you can see here, 4t is not a constant because t is attached to 4. 1 is a constant because there is no t attached to 1. So in such cases, the differentiation of that term will always be 0. And that's the reason I'm having 0 here. Now, you see 4 minus 0 is 4. So it means the differentiation of x with respect to t is equals to 4. Now the differentiation of y with respect to t is equals to 2t. Why is it 2t? That's comparing t squared to this formula. Now my n is 2. So it means I'm going to take n, which is 2. That's 2 times t squared to the power n minus 1. That's 2 minus 1, which is the same like 2t to the power 1 because 2 minus 1 is 1 and t to the power 1 is t. So that is why I'm having 2t. Now the differentiation of z with respect to t, you know, z is equals to 15t minus t cubed. That means I'll have the differentiation of 15t minus t cubed with respect to t. To differentiate this, I need to split into terms. You see there are 2 terms separated by a negative sign. So it means here I'll have the differentiation of 15t with respect to time minus the differentiation of t cubed dt, which which is equals to 15. That's the differentiation of 15t is 15. According to this formula, minus the differentiation of t cubed, which is 3t squared. T cubed compared to this formula, n is 3, so I'm going to take 3 times t cubed to the power 3 minus 1, which is the same like 3 times t to the power 2, since 3 minus 1 is 2. So that is why I'm having 3t squared here. So it means that dz dt is 15 minus 3t squared. So I need to use these three components that I've differentiated in this formula. That is, dr with respect to time is equals to dx dt I. That is the x component. So I'll just copy dx dt, which is 4, and I bring down the I, plus dy dt, which is 2t here. So I copy 2t and I write the j component, plus dz dt, which is 15 minus 3t squared. So I copy it here. That is 15 minus 3t squared, and I write the k component. So this is the differentiation of r with respect to t. But you know, we are looking for the velocity particle in terms of t. I said earlier that the velocity is obtained by differentiating r with respect to t. So it means that the rt here is v. That means the velocity is equals to 4i plus 2tj plus 15 minus 3t squared, all that k. You see, the position vector or the displacement vector was in meters and the time was in seconds, and here we are dividing position vector by t, like dividing meters by second. So it means the unit of the velocity is meters per second, and this is the velocity in terms of t.